So we're all here today. Sweet.
Wow.
Yeah, people are getting sick. My wife is sick. So 72 to 77. Please try that for homework. We are doing more trig today. Yay! You guys are getting like really emo or something.
We're very tired.
The world is a tool.
No, that's
yeah.
We're tired. Not even combination.
I'm tired. If you met me, I'm like not at all emo in any way possible.
For Christmas, I'm gonna get you Jake Paul.
No, I won't.
You better wear it to school.
Oh, my friend, he has a Jake Paul sweatshirt and Jake Paul phone case, just to like annoy everyone.
Yeah, can we like actually do the lesson?
Yeah.
Thank you. I want to get into Trig.
So, I always, now that it, like, I've done this 6 times, things get hard to remember. So I forget if I told you guys this. But in real life, in a mock survival situation, so it wasn't like we had to cross this ravine, but my patrol, my Boy Scout patrol and myself used trigonometry to figure out the most efficient way, or the easiest tree to cut down to span a gap. And we set a record on the course with trig because we didn't solve it the way they were anticipating. So, well, thanks. But 1, Scouts are sweet. Be a scout. It teaches you great stuff. 2, trig is really, really, really useful. If you ever want to go into anything, oh, come on. You have to admit that trig is at least useful in the realm of the things that your math teachers teach you.
Oh, absolutely. Trig is extremely useful in life. It's just if I had the opportunity to undermine, you understand?
All right. She's acting like,
yeah. No, trig is useful. Don't undermine that. I just wanted to make it.
And it's really easy, right? Like once you figure out how it works, it's yeah. So, and we'll get to unit circle, which is the really visual part of that. So, Katoa. So, the resource page should be on here. I think it's the one that you got yesterday. No, I forgot to print these. Let me print these really quickly.
I'm sorry.
Alright, that's the first time this year.
Can you maybe not? 8:30. I didn't have anything to eat.
Alright.
B.
So, this is where CPM allows you to formally know SoCatella. So you can start checking those out. I'll be right back.
I think the hardest one is
I think we already know how to do
B
it.
is the hardest one.
Yeah, we all know how to do it.
I think I added a change to SoCatella that makes me
What?
I added art at the end. It means all relative to angle. Hey, Johnny, guess what?
That makes it hard. That makes it hard.
Johnny, guess what?
Yeah.
No, wait, hold up. Look through all the triangles first to see if any look clear. I'm done. Guess what? And for all the other triangles, it's located on which side length.
I bet you guys can do this in 3 minutes.
Bet. What?
We made a bet with our 7th grade class about Discovery Day.
Alright, wait, we can use a paper?
I told you I'm gonna go pick these up off the printer.
Why was Ava you happy?
Because they were trying to do it without.
Wait, what do we have to round to?
I normally go
You don't have to
hundreds.
solve it.
No.
No.
Do not start anything like that. We're working on some behavior choices with them. Thank you for thinking I'm mature enough to. They're not quite at that point where they can joke with each other appropriately. People probably said that. Like your guys' class.
That sounds about right.
So once you get the hang of this stuff, and you don't have to look up here, and listening is also your choice. But once you get the hang of this, that ratio or that proportion that we looked at last week is really, really convenient. So we identify what sides I'm working with, which tell me which sine, cosine, or tangent, which trig ratio we want to use. And in A, because we have opposite the angle and the hypotenuse, we will use sine Now here's the really, sorry, not 28. The important part of this is identifying how you solve the proportion.
Yeah, that's a little bit.
So whether you can just cross multiply, or whether you have to essentially cross multiply and then solve, so like do the division, here it's really easy. All we have to do is cross multiply. So you can, in your calculator, just type in 19 sine of 28. You don't even have to hit the multiplication symbol. You can literally just type 19 sine 28. Please close the parentheses because you want to get in that habit of if a parentheses is open, you also close it. And then what do we get for our x value here? So write and solve, right? Write and solve to find the missing.
I got 8.9199.
Ah, so hold on. Jenny said she got something really, or sorry, Yia said she got like four.
Wow.
That's the first time. Well, maybe the second. But I think it's the first time. You got the wrong answer, right?
What?
Did you say you got 0.9?
No, 8.9.
Oh, okay. Make sure your calculator's in the right setting. That was why I wanted us to solve one to begin with. If you get an answer that doesn't make sense, your calculator's in the wrong mode. You want to make sure that your calculator knows you are inputting degrees. We will reach a point where we input values in terms of pi. Anyone remember what that's called? The label on this starts with an R. Radians. We'll get to inputting radians. Right now we're inputting degrees. If your answer's wrong, you know you got to switch your mode. Or you can just hit mode and check, am I in degrees? So you said here we got 8.9. And then ask yourself, does it make sense? Well, it's across from an acute angle, and my hypotenuse is 19. So yeah, it makes sense. It has to be less.
What happens if, like, x and 19 were switched places? How do you solve it? And what if you know the top value?
We'll get to one of those. Yeah, one.
Well,
So which one are you asking about? One that you've already come to? Okay, D. So we have opposite hypotenuse, except the unknown is going to be in the denominator. So we set up sine 25. So I skip B and C for the moment right now. If we set up the proportion, we have the sine over 1 equal to 6 over x, right? Opposite over hypotenuse. If I cross multiply, I'm going to get x times sine of 25
so do you have to
equals 6.
divide 6 by sine?
They can essentially swap places. Because in a proportion, when we talk about means extremes, this will make more sense. So we do 6 divided by sine of 25, and we get what for this x? 14.2?
14.1972.
No, too soon. I was just checking. We can go to the 10th. Hundredths is nice, because then if somebody wants it to the 10th, you have the 100th value there to verify, do I round up or down? And especially depending on what you're doing, precision will come from that. Any questions on any of these? I'm not going to solve them all. We're going to go through and check if we all have the same answers. We'll give you another couple minutes to work. What are you inputting? Do you have degrees or radians to input? You have degrees, so you want it on degrees. I mean, I'll teach you guys the radian conversion. It's really easy.
Please not right now.
I mean, 2 pi equals 360. That's it.
Why do you say it's not this?
Pi is 180 degrees. That's the conversion factor to radians. You want to understand it?
Sure.
No, not now.
Hey, hold on, because you don't need to understand it right now. It's nice to introduce things when they don't matter. So give me your attention for 90 seconds. I'll give you a quick little unit circle crash course.
Oh.
Hey, oh, come on. Adjust your attitude. All right, give me your eyes for just a moment. The unit circle, say that the center of the circle is right here. Okay, I can't look at it. Say the center of the circle is right here. This is 1. Okay, that's my unit. The reason that 180 degrees is pi is how do we calculate the circumference of this circle? Which is 2 times the radius times pi. If the radius is 1, this distance is 2 pi. Right? Because 1 times 2 pi, or diameter, 2 times pi, 2 pi is going to be the distance around. The radian measure is how far this has opened, how far this has traveled. It's talking about distance on the arc. And that's the answer. So we'll get to that when you need to know it. But so that it starts to get in your brain, that's all that the unit, and trig is really all based around the unit circle, but you can't just dive into that. So we did 2 sine ones.
What?
Which one's a cosine one?
G is impossible. H.
No.
G? Okay, let me check out here.
Yeah,
It's
it's
0.
It's just 0.
Oh.
Tangent 0.
Because if you have opposite and adjacent, it would be tangent. The tangent of 0 is 0, right? So the arc, that's telling you this has open 0. The ratio, I mean, so yeah, it's 0.
Technically, that's not a 90 degree.
Technically,
Yes.
But you know, that can't be time because 0 can't be a measure.
you are correct.
Ah,
So it can't even really be a triangle.
exactly.
Any of these use cosine?
Yeah.
Did you say D? Yeah, so when I have adjacent and hypotenuse, we know we're going to use cosine. Again, we can swap places. Do 18 divided by the cosine of 61. What do you get for C? We'll just check that everyone has the same answer. 32.47.
I got 37.5.
I got 37.1.
I got 37.1.
Oh, wait, then I did something wrong. 37.1. Okay, I'm going to say that I did something wrong.
Alright, check your math. Come on, let's
Yeah,
investigate
you got it
this.
in here. I did 37.13.
That's out. Yeah, check which trig you use.
I
E,
used cosine.
again, you have cosine. So cosine of 60.
Or, wait, it should
B?
be C.
C. E.
Oh, E, okay. Nice.
I mean, I was looking for cosine ones at the moment. So that's why I went to E. So cosine of 60 will equal
Wait, you did
Then-
cosine for C.
adjacent hypotenuse.
Shoot, I got it wrong.
Ah, adjacent and hypotenuse is cosine.
No, but I was worried about C for 37.1.
See, I'll check the trig.
Yeah, that's rounded. I just checked.
Yeah, it's 37.1.
It's like 37.12 also.
Something like that, yeah.
37.1279. That one. But now we're doing E. So again, we can swap places. Now it's 8 divided by cosine 60, and here our x becomes 16.
Yeah, that seems oddly.
It's nearly 60.
Oh, it is.
Called math. Calm down. In a 30, 60, 90, the hypotenuse is double your short leg. So we know that 8's our short leg because it's across from the small angle. Sorry, they're both cute. It's across from the smaller angle. So we know our hypotenuse has to be double that. We have another 30, 60, 90 triangle right next to it. I'm not supposed to be giving this stuff away, but you guys are smart, and we've already looked at these because I taught, well, half of you I taught your math 1, and I know we already looked at 30, 60, 90s. So what can I do here without even using trig? Just have it?
21.
Half it, right?
Half
it. You're just giving me a hard time. You can, I forget which, well, it's how you would write it, right? How you say it. So I can have like 3 halves of something, but I cut something in half. Sorry, not 4. 21. How? Milk. What trig are we going to use there? Opposite, adjacent, it's going to be a tangent. What do we get? 10.8.
Oh my gosh. Oh my gosh. Oh, we ain't looking for it.
In H. In H, what trig do we use?
Cosine.
There.
Sine. Cosine is the other one. Sine is the one that we're talking about. Because cosine has a sign in it, so I get confused sometimes.
What?
Yeah, we're using sine.
Jenny, it's cosine.
Okay.
Adjacent.
We have adjacent
and hypotenuse.
hypotenuse.
Cosine.
It's cosine.
Jason.
Cosine, C-A-H.
Adjacent over hypotenuse.
It's also the
Oh
help
my
paper.
You make them up.
I'm glad we don't know this.
So cool.
And it's adjacent over the hypotenuse. So that one's easy to solve. 3 times cosine of 70. What do we get for x?
1.877.
Yeah, it's going to be really small because my hypotenuse
No, I
is
just
only
got
3.
0.87. It's
Wait, what?
0.877.
12.
We did not write down the answer for B.
8.
How do we know that?
Because it's a 45, 45. So
I don't want to write that. So you will notice whether you use sine. Well, type in your calculator sine of 45. Okay, then.
Oh yeah, I did that one.
What's cosine of 45?
It's gonna be 1.
What's
Oh, wow.
Sine
Wait,
45.
shoot, wait, what am I?
Tangent of 45.
Sine 45.
I got radical 2 over 2.
Yeah, that's for sine and cosine. The tangent is
I'm
1.
so confused.
Wait, but why is sine and cosine the same but tan's not?
Well, because remember tangent is slope.
True.
Oh, tan of 41 is 45 is 1. Everything else is just weird. It's something about.
Oh, I just realized the legs are
Your shot is Ava.
Oh yeah, I forgot Leanne had a
You can't eat avocados and
avocados.
Stop.
that's commercial.
Yes, but you should still stop.
I'm not going to compete with avocado.
Avocado.
So what does that radical 2 over 2 mean? I don't.
So which one is that for?
Sine and cosine, they both are radical 2.
So wait, so tangent of 45. Oh, because we were looking at. Oh. So wait, this 45 would look at the same sides. So you're saying what does the radical 2 over 2? Well, you're saying sine and cosine are both giving that to you?
Well, mine's gonna be
What are sine and cosine relating? How could they be the same?
They both do
Ava? And
a side.
one of the legs and the hypotenuse, right? And here the legs are the same. So leg length compared to the hypotenuse.
Oh yeah, we learned this.
Oh yeah.
So, what can you do with this?
Multiply.
If this is telling you leg compared to hypotenuse, okay. So if we cross multiply, I get radical 2 times the hypotenuse equals 2 times the leg.
Is that related to the unit circle at all?
I'm just gonna let this sit.
Wait, is that at all related to
It's like
the unit
11.5. 11.4.
Oh, you're talking specific to this situation.
Yeah.
I'm talking in any situation that involves an isosceles. But I'm just gonna let this sit there and marinate in your brain.
Oh, that's disgusting. That is gross.
What?
How is that
Well, how is that gross? Makes a steak great.
marinating? Why is that?
Marinating is crucial.
No, I said you
All right.
said marinate in your brain. That's
Mozzarella.
not
Marinating.
All right. Help Marta. Marta arrives for the math test, only to find that she's forgotten her calculator.
Wow.
Dum, dum, dum.
Wow.
That's why teachers have
I've never forgotten my calculator.
Alright, bring it back. Bring it back. So, she decides to complete as much of the test as possible. The first problem on the test, Marta has to solve for the length of x. Her work is shown below. What'd she do? How'd she figure this out?
You know what time of 25 is. She just solved it.
Well, she didn't really quite solve it. But.
She simplified.
Yeah,
I rearranged the equation.
So, if we talk about step 1,
She cross-multiplied.
well, she really decided her trig ratio, right? We've had a little bit of issues with this today. Carefully choose your trig ratio. Then when you're done, make sure you ask yourself, does my answer make sense? If you've chosen the wrong ratio, your answer won't make sense. In most cases. Sometimes it's close enough, it sneaks past you. But if you look critically, you can normally catch yourself. So she chooses her trig ratio. Then, to get to step 2,
She
cross multiplies the proportion. Then
multiplies it so that
solves for x, right? So essentially did what we have been doing, the whole swap places in the proportion. Now using your calculator, what do you get? What do you see for x? What is it? 68.6. Would that make sense? Sure, it's the hypotenuse. Yeah, hypotenuse has to be the longest side. 29 is my short leg. So here's the thing about your short leg. You know your hypotenuse has to be over double that. Because even if it was isosceles and the legs are the same, it has to be over double that. So when you're asking yourself, does it make sense? Analyze these things. So Ziv comes over, says he solved it differently. Ziv. He started with cosine of 65 equals 29 over x. Is that valid?
Wait, what was our answer for 68?
I want you guys practicing doing this on the calculator. So 68 point, what was the answer for x? 68.6. Is what Ziv did valid?
Yeah.
What did he do? How did he get there?
Okay, well, we found the missing angle would be 65 degrees since you're given the 25 and the 90 degrees and it has to add 180 degrees. So then from there, he just used cosine, which means digits over hypotenuse.
Yeah.
So then he would solve for it out. And then
Now.
Yeah.
Yeah, in this case, it doesn't really make much of a difference. There are some situations where you might prefer a sine over, like, compared to a cosine or whatever. You can always find the complementary angle and use the other trig function. So you have this triangle now. Let's solve for y. Is y going to be our short leg or long leg? Y for D. Y's got to be our long leg, right? It's got the bigger of the acute angles. You know our legs have to be less than 5. What trig function are we going to use? How it's set up with the 53. What do we initially want to use? Sine, right? Because we have opposite and hypotenuse. So now it wants us to use both to show that we can. So sine of 53 equals y over 5. Cosine would be cosine of 37 is the complementary angle equals. Well, oh, then it's the same thing. So wait, we get the same answer by using what as our inputs? We're getting the same ratio out, right? Couldn't we say sine and there's a situation where we can say that sine and cosine are equal? Like, what if I say I have angle theta plugged into my sine?
And cosine would have been 90 degrees minus theta.
It's just the complement. Because the complementary angles in the triangle change which one's opposite, which one's adjacent, so that they're the same side, and the hypotenuse is the hypotenuse all day long. If you have complementary angles here, with the or not inverse, but sine versus cosine, you will get the same answer. You look really into your calculator. Are you just like doing everything?
I'm just
Are you just like solving the problems of the world?
The last one that you said.
Digit calculator.
A sine number times a cosine number times a tan number.
I mean, that's how people find things out.
Oh, yeah.
Play with 470.
That's so fun.
Oh, wow.
What do you think? How could we solve for the unknown angle where we don't have an input for our trig function? When we don't have an input for our trig function, but we do know the ratio. We know what it's equal to.
I do too. Theta equals 45.
Hey.
Okay, well, A is simple.
I mean,
But how do you get that?
everybody knows that. So
How can you get that to come up in your calculator?
But that, doing that, it came up.
Using pure math logic.
Now, how do you get 45 to come out in your calculator?
I didn't.
I'm
I
guessing
know
it's
By doing this.
Guessing and checking.
How
I get it.
can you use 9 and 9
You know, it's
and trig in your calculator? Hang on to it. I'll come to you guys, but hang on to it. Like, I'll call them.
I'm proud of myself.
Play with all 3 of them. See what you can, like.
What?
So, right now. I don't know.
It'll work.
If it works. Wait, what?
What?
Where does that come from?
Yeah, that's just tangent 1 degree.
Oh.
No.
Theta
You literally inputted 1. Like, sorry, I thought you were saying tan to like the first power was tan 1. What trig function do we use in C? What would you set up? Yeah, adjacent, right? So cosine.
I have all the equations set up. I don't know how you solve them.
So
I know.
I got it.
if we had, we'll go ahead and make this degrees just for fun. Or if you want to think about it,
Got it.
we'll make this theta.
I got it.
If we had 3 times theta,
I got it.
calm down, I'm gonna get there. What do we do and why? Ryan. Why do we divide?
Wow, such math terms. It leaves the theta alone.
Isolates theta. But why? Why do we choose division?
Because math.
Do you know? Starts with an I, is what I'm making for. When we talk in mathematics about the operation that undoes something, that is like the opposite of it,
Inverse?
the inverse. What we do here is division because it's the inverse operation. So, Owen or Colin, I don't know which one of you guys had your hand up first a few minutes ago. What do we use, let's say in C, because I have an easier place to write, to get theta by itself? Owen or, I mean, you guys had your hands up a long time ago.
Okay, well, I think I was on the right track, but now I'm a little bit insecure. I did the second.
You're right, Owen.
I did the second cosine, so cosine to the negative first.
Oh yeah, we did.
Now, if we analyze what a negative power is, think about a 3 compared to 3 to the negative 1. It's 1 over 3 because a negative exponent tells you that you essentially have divided by something that many times. So this is really like, do not write it like this, but it's like dividing by the cosine. Now the reason that we're never going to write it like that is over on the right side of the equation, we have to be able to formalize what we're doing. So the right side of my equation, we would write the inverse cosine, because what I do on one side, I got to do on both sides, of 5 over 10. Does the dilation of the ratio matter? Like, what if I type in inverse cosine of a half?
No.
Why?
1/2 just simplified.
Because the unit circle. This is why we are able to get theta as an angle of, sorry, what did you guys get?
660.
And we could have identified, if we assume this is our short leg, half of hypotenuse. What do we get for theta in B?
11.3.
What do we get for theta? Okay, we already talked about this.
1.
90.
So, let's talk about our learning log together. Because I know that if I ask you to write, that'll go down.
Maybe not.
Homework done.
So hold on. We already formally talked about tangent earlier. The tangent ratio, somebody said very quickly and like very directly, well, it's just slope. right? Because it is our rise over our run. That opposite over adjacent. But what about if somebody asked you, what does cosine relate? Or sine? And don't just give me opposite hypotenuse, that stuff.
Without that stuff.
The ratio between the long leg and the hypotenuse.
Yes, thank you.
We gotta be mathematical.
Cosine is that adjacent length. So sine and cosine are very related, right? They both relate to the hypotenuse. Height and length versus the diagonal. So imagine that this is like climbing a hill, that San Francisco problem that we had yesterday, which I can look up some pictures of that today since we have time. The cosine relates your horizontal to your diagonal, or your actual distance of the travel. Your sine relates the change in height to the distance that we travel. Two different ways of comparing to the diagonal distance that we travel, or that like distance on the hill. Any other questions about trig ratios? Yes. Most definitely.
For the first time.
Don't ruin that. Either you two